2.5, transformation of functions. So here all our different parent functions isn't it beautiful? I mean, you can pause the video and just like look at this for a while because parent functions, man. Let's get into the transformations though. It does not matter what the parent function is. We have some key spots. Notice I'm not going to be putting anything right here yet because it really depends on the parent function. What do I mean by that? Let's say if this, I'm not going to use this one, a little bit more easier. Let's say if I start off with this. Here's my parent function. These transformations are going to be the same. It doesn't matter the parent function. So A value, the absolute value. So whenever you're dealing with the stretch or compress, oops, I forgot the letter. If this number is greater than 1, it will be a vertical stretch. I didn't spell stretch right, but you'll get it. If this number is less than 1, it's going to be a vertical shrink. If this number is negative, if A is negative, it's going to be a reflection over the x-axis. Now we get into B. Okay, notice how this B, I put this in parentheses because this B is important around parentheses. It's kind of the opposite. So looking at B here, if the absolute value of B is greater than 1, it's going to be a horizontal shrink. If B is less than 1, the absolute value is going to be a horizontal stretch. And if B is negative, it's going to be a reflection at that y-axis. Okay, that's our A, our B, and then our last one is our C. Our H and a K. H moves left and right. So if H is positive, it's actually going to move to the left. And if H is negative, it's going to be moving to the right. And K moves up and down. If K is positive, it's going to move up. If K is negative, it's going to move down. Now again, I wrote this in there. However, it can be with any parent function. So that would be it with a squared, cubed, a root, greatest integer function. The reason I'm saying all that is because these transformations are the same. So if you can kind of understand these transformations, it doesn't matter about the parent function. So in looking at these first things, a lot of times what I tell people is, look, is it on the inside of the parent function or outside of the parent function? Well, my parent function is x cubed. So this is on the outside. Adding, subtracting is always left, right, or up and down. When it's on the outside, this is going to move it down 1. Outside, that's my k value. This one, here's my parent function. If you need to, write out your parent function over on the right-hand side. This is on the inside of my parent function. Remember, h value is always going to be opposite. So this is going to be left 2. Pause the video and try to do the next 2. Up 5 for C, right 7, down 1 for D. So for this example 2, this is my original function. Here it says x to the 4th power. Saying, write the equations for both of these. Well, first if I look at this, this is going to have a reflect over, it's going to reflect over my x, and it also has a shift up. Up 2. So if I write this first one, right over here, I should have put a space. Again, my parent function is to the 4th. A reflect over the x is going to be a negative a value. If you want to write a negative 1, go for it. And then I have my parent function. I don't have to put that in parentheses. I just am. And then a shift up would be plus 2. I want you to pause the video and try to do B by yourself. So it's a reflect, and it's moving to the right for us. Remember, inside the parent function is always opposite of this. So let's look at this. Just looking at this, describe in words. So again, the first thing I'm looking, where is this? Well, this is multiplying. Multiplying is my A or my B. It's multiplying on the outside. So this would be my A value. And if A is negative on the outside, this is going to be reflect over the x-axis. Looking at this one, because you're going to pause and do these 2, this will be a reflect over the x-axis right there, over the x, and then this will also move it because it's on the inside of my parent function. It's going to move it to the right 2. Now, I want you to pause the video and try to do this one. So you should have gotten reflect over y-axis because this is the b and it's negative. This is where you have to be careful because of this. When you have this, you have to make sure to create a b. If you look, turn back and see how I had the b, this was in parentheses. So I have to factor out this -1, leaving me with this. So this -1, just like up here, this is going to be a reflect over the y-axis, except now because I did that, this right here is actually going to be moving it 2 spots to the left. It's going to be shift, left, 2. Now, if you just wrote left 2, I'm okay with that. Again, this is where we have to go. I'm just going to review our transformations for vertical, stretch, shrink, and horizontal stretch and shrink. This is always on the outside of the equation, and it's when this number is greater than 1. Notice how it says absolute value of it, because the negative is either going to reflect over the x or y. The vertical shrink is when this a value on the outside, when you're multiplying on the outside of the equation. The horizontal shrink is our b value. Again, it's going to be similar to our vertical stretch. Now, these might look the same. They might kind of look the same when you actually graph them. This is when this is less than 1. Horizontal stretch is when b is less than 1. When I'm looking at these, first thing I notice is on the inside or outside. This is on the outside, so this would be a vertical stretch. This is also on the outside. This is less than 1. This would be a vertical shrink. If I look at 5, this is how it's telling me it's on the inside. So here's my function right there. It's saying it's on the inside of my function, okay? Because I would plug that into this. So if I wanted to write out what the equation would look like, it looks like this. But I'm not simplifying it at all. So it looks like this. This is where you have to be making sure that you have it written in your parent function, because my shrink here, because this b is greater than 1, the b is greater than 1, so this would be a horizontal shrink, and I should say of 2. Up here I should have said 3, and over here I should have said 2/3. Here again, I'm plugging in this 1/2. 1/2 is less than 1, so this will be a horizontal stretch of 1/2. Now, one thing I just kind of want to go over, because this stretch, shrink, and all that jazz can kind of be confusing. So if you look at this, whoopsie-daisy. So this is going to be a vertical stretch. So when I push graph, I'm going to have a vertical stretch first. This right here, because this is less than 1, my b is less than 1, this would be a horizontal stretch. So vertical stretch, horizontal stretch. And then I am going to have a vertical shrink. Vertical shrink is like pushing it down. And then I'm going to have a horizontal shrink. So when I graph these, that's first one, second, third, and fourth. So this first one, that was my vertical shrink. That's pushing it out. Horizontal stretch. Horizontal stretch means it's getting wider. That was this pink one right here. That you can't really tell it's pink. And then I had my vertical shrink. That was this one right here. My vertical shrink is like pushing it down. So it kind of looks like a horizontal, but it's not exactly the same. So even though you might think, oh, they might be the same, they're not exactly the same. So these are all different, but the same parent function. So when you're graphing, it makes it a little bit different. That's all I have for you for today. Have a great, and have a wonderful day.